And I don't know if this is going to come up or not, but today we are going to start with a poll. But I should have 20 answers. You can see the poll, right? Yeah, people are voting. I want to see how many liars we have on question number 1. 10 people voted. 12, 13. I'm at 19. Really, I'm at 20. That means one person didn't do it. All right. Do you think the test was too easy? 2 people said yes, 3 no, 15 said just right. Yeah, the class average was pretty high on this test. Turns out it was pretty easy. Maybe next time I'll make it harder for the next class. But if you have any questions on the test, you can email me or set up office hour. I was just curious, how many of you like make up a study sheet? One semester I did it in class and people are like, oh, never thought of doing anything like that. Writing information down from each chapter, especially chapter 9. And are we allowed to use the black screen of death on assignments? Well, 5 of you, I'm telling you now, you're going to lose points. No more black screen of death. I gave you what you need to do to add some color and font size and different things. Some of you might want to figure out how to do clear screens to clear your screen and so on. But the 5 of you who, said that, are we allowed to just have the black screen of death? You'll start to lose points when you submit assignments. Any questions on?
What is where's the black screen of death though? I'm only aware of the blue screen of death.
So right now we have that output screen. Yours is blue. Most people, when they run their program, it's black.
Is it the command prompt?
Yeah. When you run your program,
Okay.
that's the black screen of death. I gave you a way to fix it. You should be making your programs sell themselves a little bit more than what they are right now.
Wait, so you want them a different color, right?
Yeah, give them some pizzazz. Did somebody do a couple of you put it in the last program? Does anybody have that close by? Let's see who's quick.
Yeah, I do, Professor.
Go ahead. Throw it up on the screen. Run it once. Did it compile? It didn't come up for us. Did you run it?
Yep.
Oh, here
there it is. Can you see?
There it is. At least that's gray. Now, a couple of other things. Where is it on your screen? It's way, 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 way up there in that upper left-hand corner. Way up there. Here we go. Annotate. Yeah. Draw. Yeah, it's way. Oh, wait, draw an arrow. It's way up there. Yeah. If you were trying to sell your product, would you want it to be way up there? Or would you want it to maybe be over like about right there? So that when, it's eye appealing in the center of the screen. This is black on gray. Change the font size. A bunch of that information was given to you in that block of code that I gave you on D2L. All righty. All right, you can stop sharing. I'm going to change my camera to here. And I'm going to change my view to speaker. So in the last class, we started talking about C strings. C string. What's a C string?
Character array, basically.
Exactly. It's a char array. Okay, this goes old school. Just like in Java, there used to not be a string class. It had to be written for us. Okay, and it's included automatically and includes all those methods that go along with strings like len and so on. C string is legacy code. It's the older code. In C, if you took a class in C, you know, you would be dealing with C strings, but it's a character array. Give me a little bit more. What else you have going on with the character array? So if I started putting in hi mom, I put in H, I put in I put in a space, I put in M, O, M.
And then null at the end.
Yeah, I need a null at the end, a /0. So whenever I create my size of my array to store these characters in, character manipulation is not so bad, but when I store it, I need to make sure there's always room for one more. A couple of the programs, the code listings, what number were they showing you? They were making the array of size 80. Does anybody know why they were using size 80? Well, in the old days, our monitors used to be 80 columns by 26 rows. Yep, 80 columns, but we didn't have font sizes and we didn't have windows and GUIs and everything. We had C:/, 80 across, 26 down. Those were the good old days. So that's old school when you start to see that 80 come up. So you got the idea of C strings. The chapter before it, we had, or the two sections before it, one section talked about characters that return Booleans, character methods, and then we had other character methods that return characters. And hopefully you all got to watch the video, and a couple people chuckled about one or two things I said in the video. It was as good as me being live, right? Let me see some thumbs up. No, that was almost a thumbs up. That no, media, okay. Live is still better, but it was better than just missing class and scrambling to catch up. All right, so what are we going to today? We're moving on. Section 10.4. We're going to start talking about C strings. You did have some code listings that hopefully explain some things as you went through. But with C strings, we have a library of methods. Okay, I know I need to include C string. So whenever I want to work with a C string, I need to include it. My first note is, hopefully when you went through the book, you saw all of the bullets. And whenever this author does bullets, I like them. On page 569, when we start working with C strings and functions to go with them, you must pass one or more C string as arguments, okay? So I'm going to start now talking about some of these functions in a second. This means that when you pass the C string, it's either the name of the array, okay, a pointer variable, which we're now experts on. Arrays and pointer variables, array name has the address, the pointer variable has the address, or an actual string literal. So when we come back and we start talking about this first one, which was strlen, I could pass in Thomas Edison if I wanted, a string literal. I could pass in the name of the array. Okay, the name of the array is name and different things. So when I get ready to start with all the functions that deal with C strings, I want to remember that I have some options of what I can put in as an argument. All right, strlen, we clap our hands, we're happy. That's an easy one, right? Tells me the string length. So even though I see Thomas Edison there and I want its length, Do I count the /0 or not? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And if you can see down here, the length will get the value of 13. It does not keep that null or count that null, excuse me. All right, so we had some more string functions, right? String length simply gave me the len. strcat. What did strcat do?
Concatenate.
Concatenated, right? Took one string and added it to the next. And from my book, you know, all of a sudden I make a note, make sure we have enough memory because that's going to become important. CAT stands for concatenate. The other day, I think it was this class, I heard some people talking about concatenate. strcpy. strcpy. Do we know what that does? Well, hopefully you look through. One of the problems is to always remember in C++, we do not have bounds checking. So we could get in trouble with bounds checking. You know, and again, Gaddis does a good job. I create an integer array, size 13, and I want to store Albert Einstein in name. We know it's size 13. Can I store it in there? No, because it doesn't have room for that slash and /0, right? That null character. All right, I come down here. String 1 of size 10 has hello. String 2 of size 10 has world. I come in and I say, copy what was in string 2 into string 1. So when I print out hello, or string 1, it was hello. String 2 was world. I copied it over. I copied world over. So now they are both, in fact, world. So I have a couple of basic functions. strlen, strcat, strcopy. Okay. Now I have a couple of the same, the concatenate and the copy, but now it has an N in it. What does the N stand for in strncat and strncopy? Nobody? This time I want to concatenate. Say my first string is of size 20, but I fill the first 12. When I want to copy or concatenate the second string in, I'm going to add another argument that says, hey, don't copy all of them in because it'll get too big. For example, first one is 17, the second one is 18. I fill welcome. I fill North Carolina, to North Carolina. I print them out, welcome and to North Carolina. Before I do string and cat, I want to make sure that I'm only copying over this many characters, which it looks like it's going to be to North, because otherwise I'm out of bounds and everything's going to get all messed up. So this guy in line 10, quick calculation of how many characters I could copy over. So the N is an extra argument right here under max chars that tells me how many characters out of string 2 I want to concatenate onto the end of string 1. And the same with concatenate N with copy as well. Questions? I'm going through these quick. They only need, go ahead, Dario.
Can we use vector and forget about size?
No, because we're talking about C strings here. There is no C string. You want to use a vector of characters. Now,
Yeah.
if you get a job and they say, okay, our language is C, then you're going to have to know how to be able to work with these old C string functions. Good question. I
Okay.
understand what you're asking. I keep answering questions. I'm not going to. I need to know what str is. I have no
String.
string. Yeah, but what does it do?
Look, I think it kind of locates part of the string within a string.
Yes, it will return an address, an array element, an address of where a substring is in a string. So I start with my string array. I get a pointer because this is going to be the location where it is. This is important for your next program, folks. So I get a pointer so I can store where it is. My pointer is going to get the address of taking array and looking for the substring 7. So wherever the substring 7 is, which starts here, okay, that's where that pointer is going to start. So when I get ready and print it out, you notice it prints out 7 years ago. So the str has a string pointer, or basically it's a memory location that when I print that memory location, it prints out the rest of my C string. So it's a search for a string inside of a string. Code listing 10.6 is one that you had to type in. This was kind of neat because it takes an array of characters. This is basically a 2-dimensional array. Fills a 2-dimensional array where each row is an actual TV, 327 31-inch television. Okay. I come down, I input something to look up. For example, down here in my data, if I put in CS 109 car stereo, it's going to go through and see if it can find CS 109 car stereo. How is it doing? It's using the str. It's taking a look at each line in that array, in that 2-dimensional array, to see if the substring is there. If it is, I get a position and then I break. Ow, ow, ow. That just hurts me. Ow. I shouldn't say, I should say, ouch, ouch, ouch. Because that's not the right loop to use if that's the case. All right. If it breaks out of the for loop, it comes down and it'll print out where it was, whether it was found or not. Okay, so looking for CS, it found it and printed it out. Looks for AB, it says there was no match. strcmp. A function was written to compare two C strings. Okay, it's going to return a value. If the 2 strings are equal, it returns a 0. If the first one comes before the second, it's a negative number. Otherwise, it'll be a positive number. So equal to, less than, or greater than by using strcmp. Back in Java, when we were comparing strings, we had something called dot equals, which was nice because it was either equals or not and return a true or false. But we also had strcmp, string compare, which worked the exact same as what's going on in here. Questions? Okay. You had code listings. You had some different things to look at in that chapter. Section 10.5. 10.5. Now, one of the things you have to be careful of is what version of Dev C++ you're running. 10.5, sticking with the conversions, sticking with C strings and also including regular strings in this section. If I have a C string and I want to convert it to an integer, I'm going to use this function a to I. It's going to take a C string and do a numerical conversion. If I want to take a C string and convert it to a long C string and convert it to a float. So I'm going to use this ATOI, ATOL, ATOF. The one that you'll probably use the most is A2I. A C string to an integer, A to I. If I want to switch over to modern days, if I'm dealing with a string, you know, we have all this in C++ 11. If I want to convert a string, I now use S to I. The other one was a C string. I used A to I. If I ever want to convert a string, I use S to I. And then, of course, we have long and some other ones down here. There's float and double. So it's a little more modern. So that's going one direction. The other direction, if I come over to this table, I want to convert two string. I'm able to convert to a string. So this third one is going the opposite direction. It's taking an integer value. It's going to allow me to turn it into a string using this group of functions, the two-string group. Questions? And then you typed in code listing 1010. I'm not going to go over it because I want to get into you doing some programming. All right. Groups. I'm going to put you in groups. The first program you're going to do is page 608, number 8. 608, number 8. Sum of the digits in a string. Write a program that asks the user to enter a series of single-digit numbers with nothing between them. 1, 2, 3, 4, 5. Okay. Read the input as a C string. So from the other day, how do I input a C string? Well, I guess you're going to have to look that up, right? I want you to input it as a C string. The program should display the sum of all the single digits in the string. For example, if it's 2514, it should be 2 plus 5 plus 1 plus 4. So you're going to practice. You're going to input a C string. You're going to go through it a character at a time. Somehow you're going to take that C string, a bunch of different ways to do this. Okay, but you basically want to add up the digits in that C string. Some of you are thinking of a couple of ways to do it already now. Convert it right away, break it apart, convert, I don't know, some ideas. So the first one I want you to do is page 608, number 8. The second one I want you to do, don't get too excited. This one's going to be much harder. I want you to write a program that reads in a C string, okay? And I want you to convert it to this simple version of Pig Latin. This is an easy version. Later, you're going to do a Pig Latin program. It's a little bit harder. You're going to take the I and add AY. If it starts with a constant like S, you're going to just take it and move it to the end. M, move it to the end. O, move. So in each one of these, you're going to take the first letter, move it to the end, and add AY. C string. Start with an original C string, maybe build a new C string. I'm not sure if you can insert, you know, something along those lines, but this is what I want you to do. Number 8 and number 16 at the end of the chapter.